Welcome. In this video, we're going to talk about the normal distribution. So what I have in front of you here is I've created a data set, value here of -4, clear down through +4 by increments of a tenth. And this is just to give us some data to create a normal distribution. Because it's great to see this visually. That's why we would do this, and it shows us how to use a few of the functions. So what we're actually going to do is called a probability density function, a PDF. And now there's a math formula associated with this. We're not going to dig into that math formula, but we could implement it in Excel. I guess that's an example of, even though something is complex, you can still implement it in Excel. So, but sometimes Excel is nice to us, and in this particular case it is nice to us and gives us a function. And that function is the norm function, so equals norm dot distribution. And so it's a distribution based on a specific mean and a specific standard deviation, as you can see here. So once I select this, I've put my mean and standard deviation that I want out here, so we'll be using those. We're going to be using my value for x, so in this case it will be A2, and my mean is in G. And I'm actually going, let's see, because I know what I'm going to do with this, I'm going to do it this way so that we have an absolute reference to our column there and an absolute reference to both our column and our row for the mean, and an absolute reference to the column and the row for our standard deviation. Now this is what determines whether we're doing the probability density function or not, it's called a probability mass function here, so we're going to select that by saying 0. We'll do the cumulative distribution function here shortly, but right now we're going to do this, and oops, it has a problem. So what problem does it have? As you know, G2 I've referenced twice. So as you know, troubleshooting is an important part of learning how to use Excel and do these various things. So you're going to run into problems like this, and you got to be able to look at a formula and decide what to do. I love the fact that when I click up here in the formula bar, that Excel highlights what's wrong, or not what's wrong, it highlights what I'm referencing. And when I know that I'm supposed to be referencing standard deviation, I can visually immediately see that that's a problem, and I'm not. So we need to change that to 3. And there we go. We have the value that we want here. And we will copy that down. So we'll simply control down to the bottom, select that, control shift up to the top, shift down arrow, populate all of those. Excuse me. So I just want to illustrate that we can implement this manually. I'm not going to take time to type it in. I've typed it in previously, and I am simply going to grab that from where I have it and copy it in here and demonstrate that indeed we're doing the same thing, and that is an implementation of the probability density function here. But we don't need it because Excel was nice to us and we have what we need here. So now let's plot this thing so that we can take a look at a normal distribution. So if I select all of my data, and I'm back to the top here and insert a recommended chart, immediately it provides me the chart I want, which is a scatter chart. And there you go. This is a normal distribution. And it's actually a standard normal Whoops, distribution. And it's a standard normal distribution because the mean is 0 and the standard deviation is 1. One of the things I like about setting my formula up this way is I can change the mean. Let's go with 0.5 and watch what happens. That chart shifts over here. And what if I have a standard deviation of 0.75? I can see what happens. It shortens out a little bit. Let's go with a standard deviation of 2, shortens out more. I said shorten out. Actually, as it got smaller, let's go with 0.1. It gets taller. There you go. It gets more out in the tails and less in my peak. So as it gets larger, the standard deviation gets larger. I have more centralized in that peak area and less out in the tails. So this is a great way to play around with what happens and kind of explore that. Now, that gives us a view of the standard normal distribution, or a normal distribution if we play with the mean and standard deviation. Now, the CDF does something else for us that's maybe even more helpful, and I'm going to just copy this over, and that's one reason why I put those references as the absolute references to the column A, column and row G2 and G3. But I'm going to change this from the probability density function to the cumulative distribution function by putting a 1 in there. And then I'm going to copy that down. We have the cumulative distribution function calculated in column C now. And what this tells us is the probability that a random data point from this data set is less than or equal to that value. So if we pick one of these, say row 19, that we would say the probability that one of these x's, right, that we would pick, say at random, the probability that it falls below that or equal to that is 1%, right? So it's much easier to see when we visualize this. So let's do that. Let's select and we will insert the recommended chart again here and compare the CDF with the normal distribution. And so let's pick 0. And if we pick 0 and come up here and look at our CDF output, we can see that it's 0.5 or 50%. So if we picked a random variable from this normal distribution, there's a 50% chance that it's going to fall at that point or less, so to the left here. So indeed we can slice this in half and it's equal, right? We can fold it over, it's identical, 50% to the left, 50% to the right. We have a mean of 0, okay? But we can also pick another point up here if we select 1 and come up here and look at this value, 84.13%. So if we highlighted everything from the 1 to the left, there's an 84.13% chance that picking a random value in this data set would come up in that range. And of course we could figure out to the right, we just have to do some subtraction. So 100% minus 84.13 would be what, 15.87, I believe. And so that's the value of the cumulative distribution function, or CDF. So of course the PDF can plot the normal distribution for us, give us a visual of that so we can play around with it. And we'll do more with probabilities in a subsequent video. There are many different tests for determining if your data is normally distributed or not, and you want to know that so that you can determine if you're going to be using parametric tests for normally distributed data or non-parametric tests for data that's not normally distributed. Now the reality is all data sets contain some non-normal distribution to them. So essentially measuring how close or viewing how close the data is to a normal distribution. And I say viewing because the method I'm going to show you today is a visual one. And it's called a QQ plot, a quantile plot. So what I have here is some student data. And this student, it's a lot of student data. If we go clear to the end, we can see that there are 8,239 students in this data set. And so we have the student ID, which is their order here. What we're going to be looking at today is the height in inches. Now the height is available in centimeters, inches, the weights in kilogram, weights in pound, but we're going to be focusing on height in inches. And unfortunately, Excel does not have a method, they don't have a convenient method for creating a QQ plot. And QQ plots are very good for determining visually if your data is normally distributed or not, or how close to normally distributed it is. Now it's going to take several steps for us to do this. So let's add, we're going to add a column here. Actually, there we go. So the first thing we want to do with this is we're going to find out the rank of this. And so we're going to sort it by the order, right? So by height order. So we're going to be working with the ranks. We need to sort it by height order. Now I've already added my columns here. So I'm only concerned about this one. In fact, just for the sake of this calculation, we're simply going to delete these other ones to create more room here. I'm going to leave the sex column because we will be using that. Okay, here we go. Now we're going to sort this, and we're going to sort it by the height in inches. So we go up to data, sort A to Z, and it sorts that value, height in inches. Now I'm going to insert a rank. Now, typically, we might do something like this is 1, this is 2, this is 3, and simply drag this down. And Excel is very kind to us, and it continues to count. The problem is that I'm not going to drag that down over 8,000 rows. And if I use my technique for copying those, so if I simply go to the last row and I copy all of those up, what it does is it repeats that 1, 2, 3, 4, 5, 6, 7. So that's not an effective way to do this. So other ways that I can do this, one way would simply be to start with a 1 and add, so equals C2 plus 1. And then that's an actual formula that I could copy down. But we're going to use a third way. And that third way is to use the row number to calculate this. And the reason I would use a row number is because I'm going to use several columns to figure out this formula that we need to use. And eventually you might want to put that formula in one column, and using the row allows us to do that. So we simply, the row would be equal row. It's a function that's available. And when I do that, notice it's row 2, right? So it matches that. Well, so I have to subtract 1. And of course, this would be dependent on where I'm starting. But then I can copy that down all the way. And it shows me the row minus 1, which is my rank number for these, because I've already sorted it in rank. Now, the next thing I have to do is I have to figure out the quantile. Oops, my caps lock on. Quantile. Okay, so the quantile is essentially just a percentage. So this is rank 1 out of how many. So I need my count. So I'm going to put that over here. I need my count. So that's going to be equal to count, and it is B2. And I forget what that bottom number is. So I'm going to select, oops. Now see, I didn't want to do that, did I? So we'll get rid of that. Sometimes things just happen and you don't want it to do that. So count, and I'm going to select that and do Control Shift down. So it's row 8240. I'll remember that for future functions because I don't want to keep highlighting it all the time. So 8,239 samples. And I'm also going to put something that I'm going to call a subtract. And I'm going to set that to 0.50. I'll explain that in a moment. But essentially the quintile formula that I'm going to be using is simply my rank divided by my count, which is in G2. And I forgot my equal sign. Oh, there we go. And so this gives me a quantile. Now, the problem with this is that when I copy it down, so go clear to the bottom of this. When I copy it all the way down, notice the last one is 1. Well, it would be, right? 8,239 divided by 8,239 is 1. And the next step, when I do a rank-based standard score, it can't work with a value of 1. It has to be a value less than 1. So what we're going to do is we're going to use this 0.05 to subtract from the rank so that we can have the final value be below 1. Now, this has a name. It's actually a Hazen's model, and there are multiple ways of calculating quantile. They all involve this basic formula with a few adjustments. So we're going to do a basic adjustment to this by subtracting 0.05. This is the one you'll see most commonly demonstrated. So minus, and it is G3. And we're going to copy that one down. And now when we go down to the bottom, we can see that indeed it's close to 1, but not quite 1. And so that serves our purposes here with the next formula that we'll be using. And that next formula, I'm going to call it a rank. This is kind of a long heading, a rank-based standard score. Now, you may see other demonstrations of this same type of thing that call this a z-score. And that's okay. It's a standard score, but it's the z-score of the rank. And not to be confused with the z-score of the data value that we've looked at before in a previous video. And so just as a reminder, that would be the value itself, or x, height in inches in this time, minus the mean divided by the standard deviation. We're going to use a different formula to have a rank-based score, but it essentially does the same thing. It puts it in a standard score, so the units of measurement are standard deviations. So that formula, we're going to use what's called the norm S invert. So it returns the inverse of the standard normal cumulative distribution. So we just looked at the cumulative distribution function. So this returns the inverse of it, and we're using S for sample because we have a sample here. And so we'll be using this one, and it simply takes the probability, which is in this case is our quantile. So we're going to do D2. Okay, so that's in standard deviation, right? So it's minus 3.8 standard deviation. And we're going to copy that down. All right, and notice that this one is 3.84 positive. I'm going to create the QQ plot. Now, because Excel doesn't have a shortcut, an easy method to do this, I'm just going to create it manually, one step at a time. So I'm going to insert a scatter chart. Now notice when I do that insertion, there's nothing there. And so I'm going to have to select my data, and I'm going to add to this. I'm not too concerned about the series name, but my X value is going to be my ranking here, my standard score. So the units of measurement is the standard deviation. And my Y value is going to be that height. Let's just get back to the top here. That height in rank order. And we'll create our chart to get back up to the top to see it. Now, this is a start. It's not finished yet. I have to do some various things. So let's change the title so we know what we're talking about here. This is a QQ plot, and it's for all the students that are in this list. Now, I want to add some labels, and I want to add a trend line. And we're going to be adjusting some of this stuff. For example, you can't really see the trend line. But what I want to do is make sure that we know what we're looking at here. And so this is my standard score. Actually, it's my rank-based standard score. Rank-based standard score. And this is my height. We'll add in inches. Okay. So now there's some things I don't like about this. One, it goes clear down to 0. I don't need it to go down to 0. And also I don't like that the trend line is in the same color. So if I go over here to the chart formatting area, I can select my horizontal axis, and I can decide the range of that. Now it's -5 to -4, or I'm sorry, -5 to +5, and I know that it only has to be -4 to +4, so we're going to set that. Now my chart contents cover most of it that way, so we'll set the vertical axis as well. Oops, not the title. Oh, I already did the horizontal. Sorry, I'm looking for the vertical. Here it is. I didn't go down far enough. Vertical, and we're going to go, and I believe we need 52 to 82. You would, yeah, that'll cover all of it. You would need to be familiar with the data to know what to select there, and I was playing around with this, so remembered those. Now, for my trend line, I'm going to go over here, and I'm going to change the color of it. Now, when I do this, Excel gives me a warning because, okay, things are getting complex here. We have a lot of data. This is, Excel's just giving you a warning. Hey, things might take time. And they don't really take time, but it's a nice warning. I'm going to make it a little thicker, and I'm going to make it a solid line. So now I can actually see that trend line. And this is what you want in a QQ plot. We can see that the data itself follows that trend line very closely, with the exception of these ends. Now, a QQ plot tends to emphasize, even exaggerate the ends a bit, any differences in the ends a bit. So we're mostly focusing on variations here. And we see a little bit of a rise and a slump there, but not much, all right? So now we can go further, and we can do things like our descriptive statistics for this height, right? So let's do that. Let's go to our data and add descriptive statistics through the data analysis tool pack. And we're talking about height in inches here. Okay, and it's not wanting to. Okay, let's go back. What did I do wrong? Input range. Yes, I want an entire range in this input. I'm not sure why it's not allowing me to select that. Okay, I am going to, sometimes things happen. I'm going to go B2 to B8240, which is the range that I want. Actually, let's say B1, and I'll include the label. And we're going to do the output range at, let's go with H5. And we want our summary statistics. So here we go. Our mean. What we're interested in here is the kurtosis and the skewness, and notice how small they are. So this gives us an indication as well that this is more normally distributed than it is less normally distributed. Not exactly sure how to say that. It's not perfectly normally distributed, but we can treat it as a normal distribution. Now, there's some ballpark things you can do with skewness. So if the skewness is, the absolute value of the skewness is 0.5 or less, then you're looking pretty good for normal distribution. Kurtosis, a little bit harder. We have to actually do some calculations with what's called a standard error of kurtosis, and we can also do a standard error of skewness. Perhaps we'll cover that in another video demonstration. So here's an example of a QQ plot for that. Now I left the sex here so we could actually separate this out for female and male. I'm not going to do that because of time here. I've demonstrated it once, and you can certainly review that to see how that was done. But what I have already completed and I want to show you is that Titanic data, and I've done a QQ plot here. And this is for age, and you can see there's more variation in it here, but still not a whole lot of variation. And if you go over to the descriptive statistics, you can see that that skewness is just below that 0.5 range. So we can deal with age as being normally distributed. Now, the other thing I want to show you is the histogram. It's, you can look at a histogram and kind of think about normal distribution, but it's really hard to tell, right? With this dip here, we've got a longer tail on the right-hand side. If we go back to this one and we produce a histogram, and we don't really need these divisions down here, so we'll just get rid of that. And so this would be our histogram. And this is the height. Okay, so this is informative, but again, what do you do about this? Are you worried about it when you're trying to determine if it's normal or not? I think the QQ plot, you'll find, is a much better method of determining that in conjunction with looking at your skewness, but it helps to look at the histogram as well. So back to the Titanic data. We have the QQ plot for age. Doesn't look bad, right? But if we go over here and we look at the QQ plot for fair in British pounds, oh, okay, now we're getting quite a bit of variation here. And in fact, the skewness supports that. It's 4.77, and the histogram supports that as well. It's, it's all on the right-hand tail. So histogram, the skewness, and the QQ plot can all work together to help you determine if your data is normally distributed. One other thing that I want to demonstrate or show you is the formula for that rank-based standard score, all in one formula. And so I have it here in cell G3, so I'm using that norm.s.invert. And here's my row number, so in this case it's row -2 because my data starts at row 3. I'm subtracting my 0.5 for that Hazen's model of the quantile and dividing by the count, right, of my data, and all of that plugs into that norm.s.invert function and gives me my rank-based standard score all in one formula.